topic is about inferring that the total momentum before and after collision is equal. Let's begin. Previously, we have discussed that moving objects have momentum which is affected by its mass and velocity. We also know that when objects collide, the momentum of each object involved in the collision may change. However, the momentum of the entire system is conserved. This is known as the law of conservation of momentum. The law of conservation of momentum states that in the absence of external force, the final momentum of the system is always equal to its initial momentum. Let's go back to the collision of the car and truck. By virtue of Newton's third law of motion, as the car exerts force to the truck also exerts an equal force to the car, but in opposite direction. Hence, we can deduce that each vehicle experiences the same impulse. The impulse changes the momentum of each vehicle in equal amounts. If the momentum of the car increases, the momentum of the truck will decrease with the same amount of the car's change in momentum. The law of conservation of momentum holds for the three types of collision, namely elastic, inelastic, and perfectly inelastic. This is because during collisions, only internal forces are acting and reacting within the system. There is no net external force. Let's have some examples on each type of collision. The first type is elastic collision. In an elastic collision, if two blocks collide, they will separate after collision having their own velocities. If the blocks have equal mass and had a head-on elastic collision, their velocities will exchange. Moreover, in an elastic collision the kinetic energy is conserved. Elastic collision is common in microscopic level, but unlikely to happen in macroscopic level due to the presence of external forces. In an elastic collision, when two boxes collide, they will return to their initial position after collision. This is difficult to happen due to the presence of friction. Consider a collision between two marbles of the same size and mass, on a frictionless surface. The red marble is initially at rest, while the green marble is moving. Let us solve the initial and final momenta of the system. Let us first analyze the situation. The green marble will eventually come to a stop, while the red marble will move away with velocity equal to the initial velocity of the green marble. From here, we can see that there is a transfer of momentum between the two marbles. Let us try to solve the initial and final momenta using the given mass and velocity. We can see that the initial and final momenta are the same. This means that momentum is conserved. If we will solve the kinetic energy before and after collision, we can see that the kinetic energy is conserved. On the other hand, after an inelastic collision, the two blocks will separate after, each having their own velocity. The kinetic energy of the system is not conserved. Let's use this example again. If these two marbles had an inelastic collision, let's try to compute the initial and final momenta of the system given the following velocities. Let us analyze the situation. Before the collision, both marbles are moving to the right, but after the collision, the green marble will continue moving to the right, while the red marble will move to the left. Moreover, after the collision, the velocity of the green marble increased while that of the red marble decreased. Let us try to solve the initial and final momenta using the given mass and velocity. Based on our calculations, the momentum is conserved. On the other hand, if we will solve the kinetic energy before and after collision, we can see that the kinetic energy is not conserved. If these two blocks had a perfectly inelastic collision, they will stick together after collision, moving with a common velocity. In this type of collision, kinetic energy is not conserved. Let's use this example again. If these two marbles had a perfectly inelastic collision, let's try to compute the initial and final momenta of the system given the following velocities. Let us analyze the situation. In a perfect inelastic collision, the marbles will stick together after collision having the same velocity. Let us try to solve the initial and final momenta using the given mass and velocity. Based on our calculations, the momentum is conserved. On the other hand, if we will solve the kinetic energy before and after collision, we can see that the kinetic energy is not conserved. In summary, we have learned that in the absence of external forces, momentum is equal before and after any type of collision. This is the end of the presentation. Thank you.